Welcome to Old School Chemistry. Today we're going to do the ALEKS topic, Understanding the Purpose of SI Prefixes. I want to do a really fast review on the metric system with you. So we have what are called base units. There are actually seven. The four most common that you're going to, the four of the seven most common that you'll see in this course in a general chemistry class are going to be meters, length, second, time, grams, mass. Technically it's kilogram, but we'll put down gram, and moles for amount of substance. Now when you begin to combine our different base units, you get what are called derived units. Examples would be volume, area, density. So for example, liters, meter squared, centimeter cubed, grams per mil. That's where you're combining base units. Now for all of our base units, you can apply prefixes. And prefixes simply tell us and compare amounts, okay? Where we can take big numbers and small numbers and we can change the prefix to make the number maybe more manageable, a little bit easier to read and write. These are the relationships. Now, you're not going to see a book publish it this way. I prefer to work with whole numbers rather than fractions, and I find that with my students, it's easier cognitively for them to understand. So here is my list of of the prefixes. 1 gigameter is the same as 1 times 10 to the 9 meters. Notice I just arbitrarily chose the base unit meter. I can replace that base unit for any base or derived unit. I could say 1 gigasecond. I could say 1 gigaliter. I can replace any of these meters with my derived and base units. We'll just use this as our example. 1 megameter is 1 times 10 to the 6 meters, so a million. If I have 1 kilometer, that's 1,000 meters, 1 times 10 to the 3. And then here, imagine a meter stick. If I divide it into tens, that 1/10 is a decimeter. A tenth of a meter is a decimeter. So 10 decimeters fit on 1 meter stick. 100 centimeters fit in 1 meter. 1 little millimeter, a thousandth of a millimeter would be, or a thousandth of a meter would be 1 little millimeter. If I take a meter stick, divide that into 1,000 pieces, one of those would be a millimeter. So there are 1,000 millimeters that fit in 1 meter. 10 to the 6, so a million micrometers. That is the Greek letter mu. We call it micro in the metric system. So micrometers, micrometers, that's in 1 meter. And then if you have a billion, 10 to the 9 nanometers, that is 1 meter. You can fit a billion nanometers in 1 meter. Now on this problem, they're going to have you do conversions, and I'm going to show you the dimensional analysis way to do this. I know in elementary school you were maybe taught how to just move the decimal. I want you to be able to do this with dimensional analysis. Trust me, it's going to help you so much as you move into your other science classes. So you always begin with what's given. I have 8 kilometers, and I want to go to meters. Remember, whatever you want to cancel, the unit, you put it on the opposite side of the fraction. It's just like in algebra when I have 1x times x. You and I know that x cancels. If you look at the theory, just to prove this to you, 1x times x gives you x over x, which is 1. That's why I can just cancel that out. I know it will be 1. So that's what I want to do with my units. You can imagine your units just like a variable in algebra. Treat it like a variable in algebra. I want to get rid of kilometers, that's in the numerator, so I put it in the denominator. Now it will cancel. And I want meters. Now I come to my table, which you will eventually have memorized, and I simply attach the numbers. 1 kilometer contains 1,000 meters. So my answer on this would be 8,000 meters. If I have 1 kilometer, that's the same thing as 8,000 meters. You can imagine 8,000 meter sticks, line those up, that's going to be 8 kilometers. Or if you have, 8,000 of those meter sticks, that's going to be 8 kilometers. Okay, so here, and interesting on this one, I found in ALEKS that they want you to write it out rather than doing scientific notation. So you'd actually type in here the 8,000 like that. Okay, now we're going to go backwards. I'm going to go from grams back to milligrams. So I write down my 6 grams. I want to get rid of grams, so that goes in the denominator. I want to end with milligrams. and then I come over here and I write down my relationship. We are going to have 1 gram is 1,000 milligrams. So that means if you have 6,000 milligrams, that's the same thing as 6 grams. 6 grams. Same thing. It's just that we're converting between units. Let's do our last two. Little side note, you've maybe seen, for example, on the decimeter, you could write this another way. This is what you've seen in your textbook, is that 1 decimeter is a tenth, 10 to the minus 1 meters. It's the same thing. It's the same thing. Same ratio. It's just I don't like using fractions, and I find it's easier for students if we don't use the fractions. But if you've memorized it that way, great. You can use that. Okay, we're going to go from, wow, 8 megaliters, that capital M, and I want to go to liters. So I put megaliters in the denominator, so that cancels out. I want to end with liters. Well, 1 megaliter has 1 times 10 to the 6th, a million liters inside of it. Wow, let's write this down. We're going to have 8 million liters, and that's what you would type here. You put in that 8 million. Okay, now we're going to go from 5 seconds to deciseconds. So 5 seconds, I want to get rid of seconds, goes on the opposite side of the fraction, the denominator there. And then deciseconds, that's what I want. 1 second contains 10 deciseconds. So your answer on this is going to be 50. So I put 50 right there. Okay, well done. Good job with your conversions. Do some more practice on this. I'm proud of you. Please like and subscribe if you haven't already, and I'll see you next time.